So our next speaker is Professor Anat Bremler-Barr. She's a computer network researcher, and in 2001 she co-founded Riverhead Networks that later on was acquired by Cisco Systems. Later on she became a faculty member at Reichman University, and about 2 years ago she joined us here in Tel Aviv University at the Blavatnik School of Computer Science, and her focus is computer networks and network security. And this afternoon she is going to share with us something really interesting about the combination of AI for CV's identification. So please, Anat. Thank you.
So thank you for having me. I will speak about VulnScopper, unveiling hidden links between unseen security entities. Okay. Something. I will do it like this. So, security entities, I mean vulnerability, CV. And you know CV. All the lecture, we will use the CV of libwebpp. And there is a description of the CV, and now there is an enrichment process. In the enrichment process, you map the CV to the weakness, Avi talks about it, and then you map it to the CP. Okay? Who map it? The central organization is NVD. And what is interesting to see, and you can see it in the red box, that from the time you publish the CV and until you know all the information, it takes time, okay? For example, I will talk in this lecture, it takes time to understand all the vulnerable CP of specific CV. So with time, it's update. So I will suggest a tool, VulnScopper, giving scope to the vulnerability. It predicts the links between vulnerability to product, between CV to a weakness. Currently, this is a manual process, and I will talk about the problematic aspect of this manual process. VulnScopper is an AI model. It's a multi-model. It's used text and graph. We are not the first that tackle this problem, but until now they use all text, all graph, and all previous techniques needed to retrain when there is a new CVE. So, that's why we need a tool, because we need to handle a new CVE. So we are able to do the mapping without retraining the model. And also, we are able to do enrichment according to the organization preference. So everybody knows NVD, this is a central database for vulnerability, but CNA, which is the authority organization that can issue CVE, like, for example, Red Hat, or Microsoft, or Cisco, there are 300 CNA. They also perform their own enrichment. And I will discuss a little bit that there is different views of different organizations about the CWE. So, motivation. We have a lot of CVE, and it's increasing, okay? There is a new record this year. We are over 100 CVE per day. And how the enrichment is done, security analysts try to map it. And we started this research a year and a half ago, and in February we had a great motivation because NIST stopped doing CV enrichment. They cannot cope with it, okay? So this is the NVD announcement, says we have a problem. We cannot cope with the enrichment. It was a big shock in the security, And they are looking for solution. And what I want to argue is that we need here a machine learning and AI assistant, okay? So why is it important to map CV to CP, okay? Because when a CV is issued, in many cases, you don't know the full scope of affected product, software, libraries, because the same code is in many CPs. A compliance framework required remedy within 15, 30 days. But in our paper, we show that 6% of all CVEs are updated with new CP after half a year, okay? So we have a problem. And there is a lot of CPs, hundreds of thousands CPE, it's a lot. And what about the mapping of CV to the CWE? CWE is standard taxonomy, very, very complex one. It's hierarchical, okay? I give you an example. You have a pillar, for example, improper neutralization, and there is subcategories, improper neutralization of special element injection, and then you have subcategories, and it's becoming very complex, okay? And different organizations, in our paper we use NVD and Red Hat, use different set of CWE. It's because in the CWE there is views. So NVD map it according to the view of a general mapping, and Red Hat map it according to programmer perspective, okay? So it's very complex, and in many cases we have multiple CWE, okay? I want to convince you that it's a problem, okay? So why they map CV to CWE? Because the security implementation. If you want to know how to fix and to do security measure, you need to understand what is the weakness. Also, they are using it for trends because they want to prioritize mitigation strategies. What is the challenge? Again, it's a manual process. There is today missing information in both data sets. Many of the CVs are not mapped to CWE, and there is disparities that two organizations doesn't agree. They doesn't agree because they have different views, but even in the case they use the same CWE, they don't agree. And they don't agree because people do it, and you know, when people categorize stuff with hundreds of possible categories, you have a lot of variety. So I will talk a little bit about the architecture. The ideas of VulnScopper as a black box, that it receives the graph of the connection of the history between CWE to CVE to CPE, and the description of the security entity, the CVE, the CPE, the CWE, the text there. And then you query it asking this CVE, what is the match in CWE? And the output is the list of candidates with a score of the confidence, okay? And this is the knowledge graph we use. The core is the mapping CPE to CV and CWE with more elements that you can find them. And now I wanted to give you the intuition, why it works, okay? So knowledge graph is important. It's important basically for mapping CV to CPE, because from the description you cannot know anything about the CPE beside the first CPE, the CPE that's issued the vulnerability, in our case, the Google Chrome. But if you have the history, and you know that in many cases, when libwebp product in Chrome was vulnerable to CVE, also Red Hat Enterprise Linux was vulnerable to the CVE, you can predict in this case that you should check also Red Hat Enterprise Linux. This is why we need the knowledge graph, okay? Without it, we are clueless. And why we need the language model? Because in the description of the CVE, okay, there is, in many cases, indication what was the problem. Here is out-of-bound memory write. So our solution used Ultra. Ultra is a new, very powerful model for knowledge graph. And the main idea is that it knows to deal without unseen nodes, new CVEs. And what we did, we took Ultra and entered also language model. The idea in language model, we use the embedding of OpenAI for text embedding, but we can use also other. And then what we did, we took the embedding from the graph and the embedding from the text, combined them, and gave it to graph neural network. So what was the outcome? So we check it with previous work. The first 4 rows are the previous work. What you can see that some use knowledge graph, some use language model, not both of them. Inductive, most of them wasn't inductive. And also another thing which is very important, we need to deal with scale because we have a lot of CVE, and the more information you take from the past, you will be more accurate. And then we try different models, beginning with knowledge graph model and then combination of knowledge graph and language model. And our VulnScopper was the only one that was positive in all the aspects. And the result. We tested it in transductive and inductive. Transductive, it means that you cannot take CVE or CW2024. All that is in training should be also in testing. So you take randomly links, and in inductive, you have new CVE. So what we did, we trained the model until 2023, and then take the new CV at that year and did inference on them. And the result is, you can see here, VulnScopper, very good hit. Hit 1, hit 3, it means the percent of correct answer found in the top position. Also in transductive and in inductive. But when we try map CV to CWE, we had a competition from ChatGPT. It did better than us, and also in the inductive. But when we check it not on NVD, but on Red Hat classification, that VulnScopper outperformed ChatGPT. And this is because ChatGPT learned the mapping of NVD, because this is the common mapping in the internet. We try to learn ChatGPT to forget the NVD. We didn't succeed. I think one of the most interesting results is here. We took the libwebp, the same CVE, and we try to predict which product is vulnerable to libwebp. Again, we trained the graph until this date, then inference graph of the new CVEs, and then predict what products are vulnerable. We took the first 10 prediction of our tools, and we found manually, by looking at block security, that 8 from these 10 products are really vulnerable to this CV, okay? We can also talk a lot about the problem that the CV information is not complete, okay? And this is an example. So, conclusion. I think there is a need of co-pilot assistant for security analysts, and VulnScopper is a huge step in this direction because it knows how to handle a new CVE. And we have performed the previous method, which is great for academic paper. So that's it. Thank you for having me.